All right, good afternoon. Today we're going to go over a concept from the SAT math section, which we can call the difference of two squares, or also the difference of two perfect squares, right? So the idea behind this concept are actually these three formulas we see on the right-hand side of the screen, right? So there's three formulas there, and we can use them when we need to factorize an algebraic expression, right? So let's look at the example on the left-hand side of the screen, right? We've got x squared minus 16y squared. Okay, so if we look at this, the structure of this expression, right, we've got x squared, and we've got the minus sign, we've got 16y squared, and that, fits very neatly into one of these expressions here, right? If we look at the first formula here, a squared minus b squared, right, we have that similar structure. So what we can do is we can kind of match these two expressions up to each other, right? So in this case, x squared is equal to a squared, and 16y squared would equal to b squared, right? So we're just plugging in these different expressions into that formula. Okay, so then we can use this formula to get from a squared minus b squared to this expression here to get to our answer for this question, right? So then here all we need to do is take the square root of x squared, so that's equal to x. And then for b, okay, to get from b squared to b, we would just take the square root of that, right? Or take the square root of 16y squared, and that would be equal to 4y. Right, so now that we have a and b, right, we can rewrite a plus b multiplied by a minus b into x plus 4y, okay, and then x minus 4y, right? Okay, so that will be our answer here, right? So that's a pretty simple question when it comes to applying this idea of the difference of two squares into a math question, right? But then with the SAT math section, what we see is that they may sneak this concept into a separate question altogether. So it may be a question to do with functions or a word problem, right? But then to answer that question more efficiently, to save you the time on something like the SAT math non-calculator section, you may have to apply this principle into a separate question, right? So to show you what I mean, here's another kind of example question that also kind of uses this SAT concept, right? So we have this kind of function question. We've got f of x equals to x squared minus 2x plus 1. And then we've got g of x equals to x squared minus 2x. Okay, and then they're asking what is the value of f of g of x? Okay, so this is what we call a composite function, right? This is a composite function. Okay, and then to kind of answer these questions, we need to obviously take the g of x, okay? So we need to take the g of x, the function that's in the bracket, okay? So this one here. So we need to take this expression, and we need to take this expression and put it all the way into the x variables that we see in the f of x function. So the function that's outside of the bracket, right? So we'll go into here, and then we'll go into here, right? So that would be where x goes. Okay, so if we do that, then we end up with something that's pretty gnarly, right? Something that's kind of difficult to work with. We would get this. We would get x squared minus 2 x squared minus 2. Okay, so you can see that this expression is not very easy to work with. And, if we had to kind of rearrange this expression into something that looks like one of these answer choices, it would take a lot of time, right? Which is time that we don't have on the SAT math non-calculated section. So what we can do instead, okay, so what we can do to kind of answer this question a bit more efficiently is to recall those three formulas, right? So they're there again, right? That little chat bubble. So we can recall these three formulas, and we can see if any of them kind of resemble one of our functions here, right? And if we look closely, we can see that this expression here from the very bottom formula is a nice match. Okay, it's a nice match to this function here, right? So what that means is that we can kind of rewrite x squared minus 2x plus 1. Okay, we can kind of see the similar structure there. Okay, and we can rewrite it as x minus 1 squared, right? And to prove that they are actually the same thing, right? All we need to do is multiply that again, right? X squared minus 2x plus 1, right? So they're the same. Okay, so if we rewrite that function into f of x minus x squared x minus 1 squared, okay, then that makes our job a lot easier, because then all we need to do is we need to take this expression again from g of x, put it into this x here, okay? So then we get x squared minus 2x, okay, minus 1 squared. Okay, we remove that bracket, we get x squared minus 2x minus 1 squared. Okay, and we can see that this expression is a match for answer A. Okay, so that's our answer, right? So we can see, using this question, how by applying principles like the difference of squares or kind of these very useful formulas, we can answer these SAT Math non-calculated section questions much more efficiently. It saves us time. Okay, and then we don't have to work with really awkward expressions like what we had earlier before we recognize that we could apply this principle to this question here. Okay, so I hope that was helpful. And if you have any more questions about SAT Math Prep or the SAT test in general, you're always welcome to contact us at The Edge. We're just a phone call away, an email away, and we're very happy to help you with all your test preparation needs. All right, so thank you very much.